For today's lab, please go to week 5 folder, and in week 5 folder please go to assignments, and in assignment you will find lab 3 document. So open the lab 3 document. The objective of this lab is to learn the relationships between the acceleration and the force on an object, and the acceleration and the mass of an object. So in this lab we will apply the concepts that you learned in your previous lab. So some of the concepts that you learned in your previous labs are the meaning of dependent and independent variables, the meaning of directly proportional and inversely proportional relationships, how to plot a graph, how to find a slope from the graph, and how to write the relationships between the dependent and independent variables in forms of equations. So you will need to use all these concepts in this lab. Okay. So first thing is I want you to define what the acceleration is. You already learned the definition of acceleration in the videos on Blackboard. The next part is a common sense question. It's asking how do you change the velocity and velocity of an object in your real life. So let's say you are driving a car at some velocity. Now if you want to change velocity of your car, so what do you do to change the velocity of the car? The next part is making some prediction, which is the hypothesis. So the first question is, suppose you pushed a box on a smooth table with 10 Newton force and produced the acceleration of 1 meter per second squared. So let's say you have a box on a table, okay, and you apply 10 Newton force on that box, which produces the acceleration of 1 meters per second squared. Okay. Now if you double the force, okay, keeping the mass constant, you don't change the mass of this object, but you double this force. Now if you apply 20 Newton force, okay, keeping the mass constant, how will that change the acceleration? Okay, so that's what you need to decide. Likewise, if you triple the force, okay, keeping the mass constant, you do not change the mass, you now apply 30 Newton force. Okay, so how will that change the acceleration? Okay, likewise, now if you quadruple the force, okay, so you use the same box, do not change the mass of the box, but now you apply 40 Newton force, which is 4 times your original force. Now how will that change the acceleration? Okay, so you need to answer that. So from the results in part 1, what can you say about the relationship between acceleration and force? Okay, so you need to think about the relationship between acceleration and force, whether the relationship is direct relationship or inverse relationship. Direct is when, so direct relationship is when you increase x, y also increases in such a way that if you double x, y is also doubled. If you tripled x, y is also tripled. Okay. If you quadruple x, y is also quadrupled. So this kind of relationship between x and y is called direct relationship. Inverse relationship is the relationship between two variables y and x, such that if you double x, y would be 1/2, okay, reduced to 1/2. If you triple x, y would be reduced to 1/3 its value. Okay? Which means if you increase x at some proportion, y would be decreased at the same proportion. Okay? In other words, if you quadruple x, then this would be reduced to 1/4. So this kind of relationship is called inverse relationship. So you need to decide what kind of relationship is there between acceleration and force, and how do you know that? Now let's look at this third part. In this part, you have a box on a smooth table, just like before, and the mass of the box is 1 kilogram. So this is 1 kilogram. Now you apply some force. Okay, let's say you apply 10 Newton force, and that produces 2 meters per second squared. So you apply 10 Newton force on 1 kilogram object, and it produces 2 meters per second squared. Okay. Now let's say you double the mass. Okay. So you have now 2 kilogram object, but this time you use 2 kilogram object, but you keep the force constant. Okay, so you do not change the force. So this time you keep the force constant. What you change is you change the mass of this object. Now, how will that change the acceleration of the object? So you use the same force as before, but you now double the mass. Okay, so you change the mass from 1 kilogram to 2 kilograms. So how will that change the acceleration? Likewise, now you triple the mass. Okay, so you have now 3 kilogram mass, and you apply the same force. So you apply 10 Newton. Keep the force constant, but triple the mass. So how will that change the acceleration? Okay, if you triple the mass, will the acceleration be tripled, or will it be 1/3, or will it be doubled? Will it be 1/2? So you need to decide how changing the mass changes the acceleration, keeping the force constant. Likewise, if you quadruple the mass, okay, so if you use 4 kilogram and you apply the same force, 10 Newton, how will that change the acceleration? Will the acceleration be same, or will it be doubled? Will it be quadrupled? Will it be 1/2? Will it be 1/4? So you need to decide that. And based on your result, you need to decide what kind of relationship is there between acceleration and mass. Okay, so you need to decide whether the acceleration is directly proportional to force, or is it inversely proportional to force. Again, direct proportional is when you increase one, the other one also increases by the same proportion. Okay, that's the direct relationship. If you double this, this also doubles. If you triple this, this also triples. That's the direct relationship. Now inverse is, again, if you, let's say you have two variables, if you double this, this would be 1/2. If you triple this, this would be 1/3. Okay, 1/3 times. If you quadruple this, this would be 1/4 times the original value. So that's the inverse. This is the inverse relationship. So you need to decide whether there is a direct or inverse relationship between acceleration and force. Okay. Now for the actual lab, you need to go to this link. So open this link. Okay. And once you are on this side, click on this fourth one, acceleration. Double click, and then you'll see this. Okay, so once you are on this page, there are a couple of options here. So if you check these boxes, this will show the values on this page. So if you want to see the force, the value of force, you click on this, that will show you the net force. So you click the values also, and then the mass will also be shown. We don't need the speed, but we want to know the acceleration. Okay, so check all the boxes except speed. Now there are two parts in this lab. For part 1, so you will have a 50 kilogram box by default on this platform. So start with that 50 kilogram mass, and then for part 1 we'll keep this mass constant. Okay, so for part 1 this will remain constant, and then we will set this friction to 0. So we'll consider the frictionless surface, so drag this to none, so we don't have any friction. Now what we will do in this part is we will apply different forces on this box, and then we will measure the acceleration produced on the box. So for example, if I apply, let's say 50 newtons, so apply 50 newtons, that produces the acceleration of 1 meters per second squared. Okay, so for 50 Newton force, acceleration is 1. Okay, let's recheck that. So for 50 Newton force, you see the acceleration on the bar, that's 1 meters per second squared. Now you increase the force to 100. Okay, so for 100 newtons force, acceleration is 2 meters per second squared. Okay, so for 100 newton, acceleration is 2. So I want you to find acceleration for 7 different forces. So you use other forces and find the acceleration. Okay, so you go all the way to maybe you can do it at 50 Newton interval. So 50, 100, 150, 200, 250, 300, 350. You can go all the way to 350 Newton and then see what's your acceleration for the forces. And then you write here the mass of the box. So what's the mass of the box that you used, 50 kilogram. Again, you will be keeping this constant. Okay. Once you have all the data points, the next thing is you will be plotting the acceleration versus force graph. Okay, so you will need to use a graph paper. If you do not have a graph paper, on the back of this lab you have this graph sheet. So use this graph sheet for your graphing. Okay, so in order to plot the graph, you first determine which one is dependent variable and which one is independent variable. So we see that acceleration changes as we change the force. So that means force changes the acceleration. That means force is independent variable and acceleration is dependent variable. In other words, acceleration depends on force. And last time we learned that dependent variable goes on y-axis. So this is y-axis, and you write the dependent variable on y-axis. Acceleration is measured in meters per second squared. And you write the independent variable on x-axis. So force is independent variable, it goes on x-axis, it's measured in newtons. The next thing is we need to choose the right scale. Okay, so last time we learned that we want to choose the scale in such a way that it covers as much of the graph as possible. In our data, we have force from 0 all the way to 350 newtons. So that means we need to choose the scale in such a way that the 350 Newton covers as much of this graph as possible. So if we choose this to be 10, one division to be 10, then we need 35 divisions to cover 350 newtons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It seems like we don't have 35 divisions, so let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So we only have 29 scales. That means we cannot use one scale equal to 10 newtons. That means we can use one scale is equal to let's say 15 Newton or 20 Newton. Let's say 20 Newton. 20. That means 5 would be 100. So 1, 2, 3, 4, 5. So this is 100 Newton. So we don't need to write the numbers for each of these divisions. We just need to write the numbers at every 5 division interval. So 1, 2, 3, 4, 5. So next 5 is 200. Next 1, 2, 3, 4, 5 is 300. Then 1, 2, 3, 4, 5 is 400. Okay, so that would be fine. Okay, we cover about 2/3 of the graph. And let's say our acceleration goes from 0 to 8. Okay, so I don't know how high your acceleration will be. So let's just assume that it's 8 meters per second square. So we want to go all the way to here if possible. So 50 is here, and that's 1. So go along this horizontal line and then vertical line. So that's the first data point. Okay, so for 100 Newton force, go up, our acceleration is 2. Okay, so that's the next data point. So for 100 meters per second squared, sorry, for 100 newtons, acceleration is 2 meters per second squared. So that's the next data point. So you draw all the data points on this graph and see what kind of graph you get. Okay, whether it's a linear or non-linear graph. If it is linear like this, then you want to draw a best fit line. Okay, so best fit line like this. And again, do not draw the best fit line with freehand. You need to use a ruler. So use a ruler to draw best fit line. So let's see what questions we have here. Okay, so what type of relationship do you see between the applied force and the acceleration? So from the graph, okay, if the graph has this linear kind of data, then that shows that this is a linear graph. Okay, this is linear or direct relationship graph. So this shows that acceleration is directly proportional to force. Okay, that's what the graph shows. Does that agree with your previous hypothesis? So you need to decide whether this agrees with your previous hypothesis or not. And then you draw the best fit line, a straight line that passes through the data point, or if the line doesn't pass to the data point, draw the line that is as close to the data points as possible. And then find the slope of the graph. You know how to find the slope from last time. You draw rise like this, and then you draw run like this, and then you find this length. Okay, so this is rise, and you find this length, which is rho. Okay, you find the ratio of rise over rho, that gives you the slope. Does your best fit line passes through the origin? You need to decide whether it passes through the origin or not. Okay, if it passes through the origin, that means there is no intercept. Okay, if it doesn't pass through the origin, let's say it passes through this point, then this is the intercept. This line is the intercept. This value is the intercept. But if it passes through the origin, your intercept is 0. So you need to decide whether your intercept is 0 or there is some value. Now this line, if it is a straight line, it is represented by this equation y equal to mx plus b, and then you write this equation in your physics form. Okay, so y in this case is, what's the y in our graph? Acceleration. Okay, and then slope, you write the value of slope, and then x in our graph, x is force. Okay, and then intercept, what is the intercept, whether it's a b, it's a 0 or some other non-zero value. Okay, so that a is some value times force. That's the equation you want. We chose the mass of the box to be 50 kilogram. Okay, now you take the reciprocal of that. Reciprocal is 1 over m, so you find 1 over m. Okay, and then you compare that reciprocal with this slope. Okay, we have this slope m, or do not be confused with this symbol m and this m. This m is the mass which we use in physics, and this is the slope m which we use in math. Okay, so compare this slope, the value of slope you got here, and this reciprocal, which is 1 over m. Now, do they look same or similar? Okay, if the values look similar, if they are similar, that means the slope is the reciprocal of the mass. Okay, your slope, this slope is reciprocal of mass. That means you can write the equation as acceleration is 1 over m, which is the slope, times force. Okay, so your equation for the relationship between acceleration and force would be a is equal to f over m. Okay, that's the equation. So you want to show that. That's the first part. Now in the second part, what you will do is you will now keep the force constant. Okay, so you will be applying 100 Newton force. Again, just like before, you keep the friction 0, and then click these boxes, and then for all the trials you will be using 100 newtons in this part. Okay, so you will be using 100 newtons. So first you start with 50 kilogram box. Okay, and you apply 100 Newton force. So that's 100 Newton force. So the acceleration is 2 meters per second squared. So for 50 kilogram, acceleration is 2 meters per second squared. Okay, we don't need to write the unit because unit is already written on the top here. So we applied 100 Newton force. For 50 kilogram box, you produce 2 meters per second squared acceleration. Now apply the same force, but this time you increase the mass. Okay, so this time we want 50 plus 50, 100 kilogram mass. Okay, and then apply the same force, 100 Newton. Newton, and then see what the acceleration is. So you saw that the acceleration here is, come on, so you saw the acceleration here is 1. Okay, so you got 1, and then do the same thing for different masses. So you keep the force constant, and then next you use different objects. You can choose other objects also to make the total 150, And then next is you choose different objects, or you can just choose this refrigerator of 200 kilogram, and then next would be 250 kilogram, and then the next would be 300 kilogram. Okay, so you want to go all the way to 300 kilograms, and then for each of these masses, by applying the same force, what would be the acceleration? So you need to find that. And once you have your data, you want to plot the graph just like before. So you go to your graph. So this time we have acceleration and mass, okay, keeping the force constant. So which one is dependent and which one is independent variable? So decide which one is dependent variable. So our dependent variable is acceleration, because acceleration depends on mass. Or in other words, by changing the mass, you can change the acceleration. Okay, so this is independent variable and this is dependent variable. Acceleration is dependent variable. Its unit is meters per second squared, and mass is independent variable. Its unit is kilogram. So our mass goes from 0 to we went all the way to 300 kilograms. So this is, let's say, 50. 1 2 3 4 5, that's 100. 1 2 3 4 5, that's 150. 1 2 3 4 5, that's 200. 1 2 3 4 5, that's 250. 1 2 3 4 5, that's 300. Okay, so we go from 0 to 300 kilogram, and then you choose the scale for the acceleration also. Okay, you can choose, see your highest acceleration. Let's say your highest acceleration is 2. Then let's say 1 2 3 4 5 6 7 8 9 10. 10 is 1, and 1 2 3 4 5 6 7 8 9 10, that's 2. Okay, so that's acceleration, and then you plot the graph. And then once you have your graph, let's say you get a graph like this. Okay, see if it is linear. It doesn't look like linear. You cannot fit this with a straight line. Okay, if it is not linear, then you need to draw the best fit curve. Instead of line, you need to fit this data with a curve. And curve means it's not connecting the data points. I don't want you to connect the data points like this. Okay, so do not connect the data points like that. That's not what I want. So what I want is, I want a smooth single curve that passes as close to the data points as possible. So you draw a smooth curve like this. Okay, again, the curve may not pass exactly through the data points, but even if it is pretty close to the data points, that's pretty good. Okay, so this is a curve, and then you answer some of the questions here. So the question is asking, does the data points look linear? You need to decide whether it's linear or not. If it is not, then you need to draw a curve. That's what it says. What can you say about the relationship between acceleration and mass? Whether the relationship is directly proportional or inversely proportional relationship. You need to decide that. And does that agree with your previous hypothesis? So you compare your result here with your previous hypothesis, and then see if your result agrees with your hypothesis. Conclusion. In conclusion, you need to write the two most important concepts that you learned in this lab. Okay, so the two most important concepts could be relationship between acceleration and force. What kind of relationship is there between acceleration and force? And relationship between acceleration and mass. What kind of relationship is there between acceleration and mass? Okay, so you can draw the conclusions about these two relationships. So that's what you need to do. Okay, so you write down your results and the answers to the questions in this sheet, and then you take the picture of this sheet. If you write this in Word, you can save this document in Word, and then you can email this to me. Okay, so email this once you're done. And the graph, you need to print this out, and you can take the picture of your graph and then send it in email. If you have a tablet with a pen, you can also draw the graph on your tablet or even on your computer, and then you can just save it and send it to me. Okay, so if you have any questions, please feel free to email me. I will be more than happy to answer your questions. Please submit this lab report by tomorrow. Okay, so the due date for this lab is Tuesday, by the end of the Tuesday.